be right here. So I want you to look at that yellow wall. This yellow wall right here. Is there a discontinuity happening right here where you see that red laser? Would you say that's continuous or discontinuous? Who says it's continuous? If there's no discontinuity, that means it's continuous. So this is continuous. And what's the Y value for that red dot? What's my Y value? 6. So 9, 10, 11, and 12, you should have 6 as your answer. So 9, 10, 11, and 12, they're all of those would be 6. All right, so now where are we going? X equals what? What's our next point in our domain? 1. Yep, positive 1. So let's look at the positive 1. So positive 1 would be right here. So let's identify what is happening on that purple wall. What kind of discontinuity do we have at that purple wall? All of these go together. So what do we have? A jump. And what did I say about a jump? Does a jump have a limit at that point? No. So that means that for 15, because they don't agree, the graph is hitting the purple wall in different places. So for number 15, the answer would be D and E. Okay. So now let's look at the left side of the wall. So the left side would be right here. So here's my laser here. I'm tracing it. On the left side, the graph is approaching what point on the y-axis? This is the left side. The left side of the purple wall is approaching what? 7. Who agrees that it's 7? So that means that for number 13, from the left, the answer is 7. Now let's trace from the right. The graph is coming up. It stops here. So from the right, what would you say your limit is? 4. And because the left and right are not the same, D and E at 1. Now, do we have a closed circle at 7 or 4? Which one is closed, the 7 or the 4? The 7. So number 16 would be 7. All right, now let's move on to 17 through 20. Okay, so 17 through 20. You always want to identify what is happening at that point. So 17 through 20 is right here at 3. Okay, on that pink wall, what kind of discontinuity do we have on the pink wall? Removable. Who agrees that it's removable? So whenever you have a removable, removables do have a limit. All 3 of these should have the same answer. 17, 18, and 19 are all the same. Because when you trace the graph from the left, it's heading towards 2. When you trace it from the right, it's heading towards 2. A limit is what does it approach, not what it gets to, but where is it going towards. And for 17, 18, and 19, they are all going towards 2. Now, so that should be 2. Now, what about 3? What am I going to put for F of 3? Do you have any closed points anywhere on my pink wall? No closed points. So F of 3 does not exist, but the limit at 3 does exist. All right, let's go to the next one. Now we're at 11 through 14. So 11 through 14, we're all talking about 4. I'm going to go ahead and draw my green wall in. What is happening on that green wall? What kind of discontinuity do we have on the green wall? A jump. Who agrees that it's a jump? So what does that mean? Which one of these is D and E? 21, 22, 23, or 24? Excuse me. 23. Who agrees with Denia that it's 23? Because that is at that point. At that point, they don't agree. So this would be D and E. Now let's look at the left side and the right side of my green wall. On the left side, if I trace my graph, what is it approaching? It's approaching X, the X value. So going towards 4 from the left, what Y value is it approaching? Where did I stop? 1. So what would that be the answer to? 21 or 22? 21. Now let's go to the right side. It's only a little bitty piece of a graph here, but where is it going towards? What is that point where my red dot is? Luke, what would you say that red dot? What's the answer for the red dot? -4, good. So that would be number 22. Now, do I have a closed point anywhere on my green wall? Yeah. Yes. Where is that closed point? It's at 1, so that would be my answer. All right, last piece. Again, I always like to start by drawing in my wall. So now I'm looking at 5. So I'm going to draw in my gray wall at 5. So here's 5. It's a little crooked. All right, what's happening at 5? It's a jump. Who agrees that it's a jump? All right, so because it's a jump, 25, 26, 27. Which one is going to be D and E? 27. So 27 is D and E. From the left side, if I trace from the left, the graph is stopping right here on my green wall. So success, what is that number right here where my red laser is? What is it approaching? -3. Good job. So this would be a -3. And then from the right, Robin, what would you say that is? Where is it going towards from the right?
From your right, I think it's going
Towards 1. And remember, it has to match. The left and right have to be the same in order for there to be a limit at that point. So what about F of 5? Do I have a closed circle anywhere on that green wall? I'm sorry, gray wall. Any closed circles? Where is the closed circle? It's at 1. Okay. So number 29 is just telling you, asking us to list where we have a discontinuity. We have a lot, right? So our first value that you're going to write for number 29 is X equals -5. That's my first because I have a removable. And then I have another one at X equals -2. And then my next one is here, and that's at X equals 1. And then I have another one at X equals 3. X equals 3, we have another removable. X equals 4, we have a jump. And X equals 5, we have a jump. All right, go to the next page. Now it's your turn. So limits are a big part of our next quiz and skills check. So I'm going to set the timer for 5 minutes. I want you to answer every single question. Every single question. This is like a little mini quiz. You can quiz yourself. So take 5 minutes. What would you put if the test was today? Don't leave anything blank. You're not sure? Guess. Every single one. through 21. All right, you should be about halfway done. Some of you all flying through. See if that's a good thing or a bad thing. Now, when you're looking at limits, because it's a graph, it should just be an instant answer. Look at the graph, write what you think. You don't have to pick up the calculator. You're just looking at the graph. So, what does it say? It's between 2 and 10. So remember, in order for there to be a limit, that means the only thing that can happen is the limit. So between 2 and 10, do you have anything other than a limit for each time? So where is it? So from here to here, not including this, so between here and here, that's 20. Do you have any, do you have a hole, do you have any joints? Or anything? So that means that every place has a limit. So that would be true. All right, y'all, let's see how we did. Let's see. Don't worry, we got more practice. Practice makes perfect. All right, let's start off with numbers 1 through 4. 1 through 4, we're looking at the graph at -3. So -3 is right here. What's happening on that pink wall? What kind of discontinuity do we have? A removable. Who agrees that it's removable? So the answer to 1, 2, and 3 should all be the same because a removable has a limit. So from both sides, the graph is approaching here. And what is that value where my laser is? 1. Now let's look at 4. Is there a closed dot anywhere on that pink wall? No. So what are we going to say for number 4? D and E. Okay, so now we're moving on down the graph. So now we're going to look at -1. See what kind of discontinuity we have at -1. All right, so now I have a green wall right here. What kind of discontinuity is here? See how it's not connected? Whenever the graph is not connected, we call that a jump. So a jump does not have a limit. So number 7 is D and E. Number 5 It's asking about this point because this point is on the left side. It's coming from the left side. And this point is coming from the right side. So the limit from the left would be -2. And the limit from the right would be a +3. Now, do we have an open circle anywhere on that wall? I accidentally took it away. Do we have a closed circle, anywhere on that wall? All right, where is our closed circle? -2. Okay, let's keep rolling. Now we're moving down to 9 through 12, and 9 through 12 are all looking at the same place, which is +2. So right here on that purple wall, what's happening? A jump. So Zadiq, what did you put for 9 and 10? For 9 you put 2, and for 10 you put 1. All right, who agrees? I agree. Because the left side of the graph is hitting here, the right side of the graph hits here. Now, did I put the same thing from the left and right? Because remember, these have to be the same in order for me to have a limit at 11. They're not the same. All jumps don't have a limit, so that should be D and E. Now, number 12, do we have a closed circle? Where is my closed circle at? 1. Okay. Now let's move on down to 4. Now, what you're asking yourself is, do you have a discontinuity? So, do I have a discontinuity right here? No, it's continuous. If you don't have a discontinuity, all of these should be the same because there's nothing happening here except a normal discontinuous graph or continuous graph. So what is my Y value right here? So for 13, 14, 15, and 16, they should all be -1. Nothing is happening there. It's a smooth road. We don't have no bumps, no lumps, no jumps. It's a closed, but the closed circle. So if the graph is continuous, that means it's a closed circle there. We just don't put it there. But every place where there is a graph, it's a closed circle. All right, let's jump down to the next one, and then we'll grade it. You'll grade it, and you don't have to tell me what you got. So we're gonna move here. +6. That's 17 through 20. What is happening? What kind of discontinuity do we have at +6? Let me zoom in right here. So what would you say that is, Cooper? What kind of discontinuity is that? Removable. Who agrees with Cooper? Removables have a limit. Okay, because the graph is approaching from the left and right, it's approaching the same point, which is 1. So 17, 18, and 19 should all be 1. But number 20, what's the answer to 20? 3. All right, so I'm going to give you the grading scale. Go ahead and count up how many you got right. So 20 through 18, that's an A. 17 or 16 would be a B. 15 or 14, a C. 13 or 12 would be a D. Anything less than 12 is not great. So you don't have to tell me what your grade was, but that kind of helps you see where you are as we continue practicing limits. Can you go to the next page real quick? I think that's the last graph. Oh, so I already gave y'all that and I made another copy. Oh, okay. All right, so now let's go ahead and go to the last page of your notes. So I'm gonna give you a few minutes. Go ahead and do that question. And I wrote in a few extra off to the side. So just take a couple minutes and do that question. We will. So if you want to work ahead and do the top and bottom, you can. So actually, that's what I'll do. I'll give you 5 minutes. Go ahead and do those two. And then that'll be the end of limits.
What are they gonna do with that? So they want to put that out for, so like, the limit at 4 will be hard.
All right, do top and bottom. Go ahead, do the top and the bottom.
You know how they come with, it's like that.
It's hard for them to jump my limits and just evaluating.
Yeah, I
Like,
think sometimes.
on G, you have people what?
Because I know this is, I know this is two people that, that's two that they all right, but this is, cause that's supposed to be that negative one, it would not just be that.
So like, when you ask for it, so like, on page, no one's here, but
I was into
Section 2.
you can see, if I was wondering, because that's part of it. You see what I mean?
Oh, yeah,
Like,
yeah,
that's, that would have been totally.
Right,
That's
right.
why
Yeah.
That would be.
Yeah,
But I
we
think
were trying to jump.
what I noticed.
Oh, it wasn't jump then, would have been.
But, oh, and another one is when it's continuous.
So like if you have the limit at negative or 0, that would be hard. Because you don't know the points.
Is it right? You should ask them something.
Yeah, we do, we have one built in, yeah.
These are the
I had to find these in a calc book. Pretty hard to find these limit graphs.
Yeah, seriously.
Oh. I was like,
See, that's my shirt in my head.
So the extra practice that you picked up today, we're not gonna work through it today, so you can put that to the side. But let's go ahead and start because I see a lot of us have started playing games on our phone, so that means we're ready. So let's go. because we're also starting 4.1, and I'm showing you your test, your test today. All right, so let's looking at this first graph. So A, B, and C is asking me to look where. Where on the graph am I looking for A, B, and C? -1. So let's look at -1. So what is happening at -1? So first of all, what kind of discontinuity is at -1? Removable. And remember, removables have a limit. So whatever you put for A, you should put for B, you should put for C. What did you put for A, B, and C? 2. Good job. Now I'm going to jump ahead to H. H, the one I added off to the side, that's asking, do we have, because remember, on the graph, this open circle means that on the graph is undefined. So right here is undefined. But is there a place where x equals -1 is defined? Right here. And what is that number? 1. All right, now it's telling us to, for D, it says look at -4. So I'm going to look at -4. So -4 is right here. So I always start by asking myself, what is happening there? What is my discontinuity? If you can identify if it's continuous, removable, a jump, or infinite, that's going to help you determine what the limits are. So at -4, what's happening? It's a jump. And what do we know about jumps? They don't have a limit. The reason why is because the left side is going to 3, whereas the right side is going to 4. They don't agree. So for question D, you should write D and E. But what about for F? What would be the answer to F? 3. All right. And then we're going to move down to +4. So that's here, that's here, that's here. All right. So what's happening at +4? It's a jump. So again, if there is a jump, we don't have a limit. But we do have a close point, and that would be at -2. All right, just curious, who got 5 or more right? Okay. All right, let's go ahead and work through our last graph, and then we'll start 4.1. We're only going to do one question in 4.1. We're just going to get started. So not a whole lot. All right, so now we're going to look at -5. So -5, oh, actually, let me go down. It's actually having us look at +1. So it's having us look at +1. +1. +1 is right here. Ooh, that's interesting. What's happening at +1? What did you say, Luke? It's continuous. Who agrees? Do we have an open circle there? Is it an infinite? Is it a removable? That means it's continuous. So what would be my limit at 1? 3. So you should put 3 for A, B, and C. Now let's look at -5. So -5, we're here. All right, what's happening there at the -5? What did you say, Delaney? It's a jump. So because there is a jump, what's the answer to D? Does not exist. And do I have a place where -5 is defined? Is there a close point? And where is my close point? 2. Okay, last one. +5. +5 is here. All right, what's happening right there on my graph at +5? It's another jump. So, Omer, what would you put for E? Does not exist. But what would you write for F? 0. Good job, y'all. How we feel? Just quick. Thumbs up, sideways, down. Limits. Okay. All right. So most of us, we're either here or here. Don't worry. I got more practice coming. So now take out your regular pre-calc notebooks. We're going to transition to 4.1. And go ahead and set up your title, your notes. 4.1. 4.1 is polynomial functions. This is homework 11. Homework 11 is going back to our book. These are the questions. It's due next Tuesday, so a week from today. So I'll give you a moment to get that title, and then we're going to work through a couple questions, and then we're finished. So don't forget, homework 10 is due Thursday. And for all my people who said that it was this or this, that means tomorrow during A lunch, we're going to have a limit party. We can all just kind of group together. That's the good part of having 5th period pre-calc. You say, Cooper? You looking at it wrong? Because you know. Oh, okay. Okay. Yeah, so homework 10 is a worksheet. Homework 11, we're going back to the book. And again, this is from Canvas, so you don't need to write it down. All right, so when we're asked to write an equation, okay, whenever we're asked to write an equation, there are 2 different ways to write an equation. You don't necessarily need to copy this down. So the first method is standard form. When it's in standard form, that means we multiply our factors. Okay? The other way is to write it in factor form. And that's when we just leave it in the factors. Would you agree that, well, hopefully you agree, that if I multiply this, I get this? Because the 2 numbers that would multiply to 12 and add to 7 would be what? 4 and 3. So if I were to pull up a graphing calculator and if I typed in this or this, it would be exactly the same. 2 different ways to say the exact same equation, okay? But today we're going to focus on factor form. All right, so I'm going to just copy down A because we may not get a chance to get to B. Because I do want to show you your tests. So we're going to write an equation in standard form, okay? We have zeros at -1, +1, and +3, and the degree will be 3. And yes, I skipped example 1. So we're going to go to example 2. Tomorrow we'll do example 1 because we have some things to glue down for example 1. So remember I said Friday you have a skills check and it's over limits and writing equations. This is what I'm talking about here. This is an example of what the question will look like, similar to this. Writing equations given the zeros. Okay, so we're gonna start off by writing it in factor form. So this is the tricky part. What do you think my factors are going to be? So y equals, so I have 3 zeros. How many factors do you think I'm going to have? That's a trick question. Anybody know? It's 3, yeah. So I'm going to make my 3 parentheses. Put your X in front of each one. So what we have to remember is that in order for me to go from the 0 to the factor, what do you think is going to happen to my sign? So what this is asking is what equation is going to give me x equals -1? X plus 1. Good job. So that means this is x plus 1. That's my first factor. So for me to get x equals +1, what do you think my factor is going to be? X minus 1. Good. And for me to get x equals +3, what do you think the factor is going to be? X minus 3. So this would be factor form. If I asked you to write it in factor form, you would be done. That's my answer. But in standard form, we have to multiply. So let's do our standard form. Now, standard form, I don't know. Because I see a shortcut that can save us some time. But does anybody recognize, I'm going to ask this question. I'm a little nervous, though. Does anybody recognize what that is? X plus 1, X minus 1. Difference of squares. That's what I wanted you to say. So what this is going, this factor, if you multiply it, you get x squared minus 1. Now, if you're not there with us, you didn't catch that, you can always make a box. Feel free to make your box and multiply x plus 1 and x minus 1. But I'm telling you, because that's the difference of squares, when you multiply this, it's going to be x squared minus 1. So now I'm going to bring down this third factor. And now we do need to make a box. We need to multiply these. So go ahead, make your box. And multiply x squared minus 1 and x minus 3. So go ahead and do that. Nobody said that second period. That made me happy. Somebody recognized difference of squares. So we got x to the power of 3. I have negative 1x. I have negative 3x squared. And I have a positive 3. Are any of these like terms? What do you think? How do we know they're not like terms? The exponents are all different. So my equation in standard form, and I realize this is very messy. Let me write it down here. My standard form equation would be y equals x to the power of 3. And I usually just go down according to the degree. That is standard form. And again, if we were to type this into a calculator, a graphing calculator, they would be exactly the same. That's the same as where we started. All right, copy down B. We're not going to work through it, but just copy.